Good morning, dear friends. In the last class, we have seen what is meant by Kirchhoff voltage law, how one can do the Kirchhoff voltage law. Today, we are going to understand the concept behind the Kirchhoff current law. In the Kirchhoff voltage law, algebraic sum of the voltage in the closed loop is equal to 0. But in the Kirchhoff current law, algebraic sum of the current in the particular node is equal to 0. For example, assume that this is the node A. There is many currents are flowing here. If you do like this, so this is I1 and you can take this is I2 and this is I3 and I4 and this is I5. So now what is mean by Kirchhoff current law? Algebraic sum of the current in the particular node is equal to 0. So now assume that this current is here, I1 is entering to the node A, I3 is current entering to the node A, similarly I5 also entering. At the same time I4 and I2 are leaving from the node. So now I am going to note down current entering to the node, current entering is equal to positive value and current leaving is equal to negative value. Current entering is equal to positive, current leaving is equal to negative. Now if you see this, current I1 is entering, therefore current I1 positive value, then current I3 also entering, so plus I3, then current I5 also entering, therefore I5, then but I2 is leaving from the node, so I am writing minus I2, then current I4 also leaving, therefore I4 is equal to 0. So this is the main concept behind Kirchhoff current law. So these three currents are entering, then these two currents are leaving from the node. These two currents are leaving from the node. So now if you see this, when we take this minus value the right hand side, we can say that I1 plus I2 plus I1 plus I3 plus I5 equal to I2 plus I4. So from this, the another definition of Kirchhoff current law is sum of the current entering to the node is equal to sum of the current leaving from the node. So the two way we can explain Kirchhoff current law. Algebraic sum of the current entering to the node equal to algebraic sum of the current leaving from the node, or otherwise the total current entering to the node is equal to total current leaving from the node. Now let us see the circuit here. There is having four loops and branches are 1, 2, 3, 4, 5, 6, 7, 8, 9. By many branches are there. So now current in this branch, you can see this is A node and this is the B node. Only I am going to consider A node and B node. Now in this A node, if you see, I1 is entering to the node, I2 and I3 are leaving from the node. So how one can write current entering to the node is positive I1 and current leaving from the node minus I2, and this I3 also current leaving from the node I3, that is equal to 0. As per the second definition, or otherwise other way of Kirchhoff current law, we can write total current I1 equal to I2 plus I3. That means I1 is entering, I2 and I3 are leaving. So this is for at node A. At node A. Now you say that at node B, in this node I3 is leaving, I7 also leaving, I5 is entering, I2 also entering. So can you write it now? I2 is entering, so I can write I2 positive, I5 also entering, I can write I5, then I6 is leaving from the node, so that a minus I6, I7 also leaving from the node, so minus I7 is equal to 0. From this we can write I2 plus I5 is equal to I6 plus I7. So this is the second nodal equation of the particular node. Here we have considered A and B node only. We can use this node as well. The node already we know the two or more elements are connected in the particular point, that is called as node. So you can choose any node. So now if you see this current I1, I1 equal to I2 plus I3, I2 is plus I5 equal to I6 plus I7. All the currents are each branch current, right? So now if you want to know the current, we can find out the voltage across. For example, if you want to know the current I2, means the voltage, if you know already the voltage across this terminal, voltage across this branch is what? VAB, and divided by this resistance R2, we can find out what is the value. From this we can find out what is the value of VAB as well. So even vice versa, if you want to know I2, you can use this. Otherwise, if you know already I2, you can use this. So similarly, in all branches, you can substitute and find out the voltage across the each node, and finally end up with the calculation of the power, etc. So this is the main application of Kirchhoff current law. So Kirchhoff current law, when we apply, that analysis is called as nodal analysis. Kirchhoff voltage law, when we apply, that analysis is called as mesh analysis or loop analysis. I hope you understand how one can do this Kirchhoff current law and how you can prove this Kirchhoff current law. In this description, I will add more problems related, problems and solution related to Kirchhoff current law. Kindly go through it. I hope you understood the concept very clearly. Those who have not subscribed this channel, kindly subscribe and like and share as well. Wish you all the best. Thank you.